Hi, so for today we're going to talk about inverse of a matrix of 3 by 3 and we're going to solve one problem getting the inverse of this matrix 3 by 3 matrix for this video. So what I'm going to teach today is only for 3 by 3 matrix, inverse of a 3 by 3. Another discussion will be made for 4 by 4. Okay, so let us try to discussed first what are the steps of getting the inverse of a certain matrix. Okay, so number one, we are going to solve first the determinant of that matrix. Okay, so we are going to get the determinant of the matrix. And then we are going to solve the cofactor matrix. So meaning we are going to apply the get the cofactor matrix by getting the determinant by the cofactor method. So we are going to get also this cofactor matrix, and the resulting matrix will still be 3 by 3. So I'm going to show you what is that cofactor matrix means later. And then after getting the cofactor matrix, we are going to apply the sign convention for a 3 by 3. Now for a 3 by 3, the sign convention looks like this. We have positive, negative, positive, negative, positive, negative, and positive, negative, positive. So we are going to apply the sign convention, meaning whatever number we get in the matrix, we are going to apply this. We are going to apply these signs in that cofactor matrix. And after getting the cofactor matrix, we are going to get what we call the transpose, okay, of a matrix. So if you have a matrix A, okay, A raised to T means the transpose of a matrix. The transpose of a matrix is simply interchanging the rows and the columns of the certain matrix. So if I have, let's say, a matrix of 1, 2, 3, 4, okay, and that is matrix A, if I'm going to get the transpose of that, that would be simply interchanging the rows to become columns. So these are the rows. It will become columns. So it will become, we have 1, 2, okay, and then we have what? This one becomes rows. So we have 3 and 4. Okay, so they interchange. Okay, this becomes the column. The 1, 2 becomes the column, and the 3, 4, which is the rows, becomes the column also. So that's how we go. Are we going to get the transpose of a matrix? And then after getting the transpose of that matrix, we're going to simply multiply it by 1 all over the determinant of A multiplied by that matrix. Okay, so first things first, we are given this type of matrix 1, 2, 3, 4, 5, 6, 7, 2, 9. Now we are going to find the inverse of this matrix. So A inverse is defined as A raised to negative 1 of that matrix. So first, we are going to get the determinant. That is the first step. So since this is a 2 by 3, we can use the basket method, wherein we are going to copy the first 2 columns, okay, and then get the determinant 2, 5, 2. This is 2, 5, 2. Okay. So again, multiplying this, we have 1 times 5 times 9, plus we have 2, 6, 7, 2 times 6 times 7, and then we have, finally, we have 3, 4, 2, plus 3 times 4 times 2, minus, okay, the other diagonal, so you have 7, 5, 3, 5 and 3, plus you have 2, 6, 1, 2 times 6 times 1, plus you have 9, 4, 2, 9 times 4 times 2. Okay, so if you get that, we just simplify the determinant. So you have a 45 here, 2 times 6, 12 times 7, so we have 14, 1, 84 here. 3 times 4 is 12, times 2 is 24, minus, of course, we have 7 times 5, 35 times 3, that's 105, plus 12, 2 times 6 times 1, and then we have 9 times 4 is 36, 9, 18, 27, 36 times 2, that's 72. So still, we first need to add this. So you have 9, 13, 1, 9, 13, 15. 153 minus, we have 105 plus 12 plus 72. So you have 9, we have 8, 189. So we have to minus, excuse me, 153 minus 189 minus 153. So of course we'll be getting a negative value here. So you have 6, and you have 8 minus 5, you have 3. So you have negative 36 in here. Okay? So this is our determinant. Alright, so we are already done with the first step. Now, the second step is solve for the cofactor of the matrix. So the cofactor matrix of the 3 by 3 will be A11, A12, A13, A21, A22, A23, we have A31, A32, and A33. As you may notice, we have a subscript wherein 1, 1 means row 1, column 1. That's the position of this element. Okay? And A12 means row 1, column 2. And we are going to get all of the values of these elements by the matrix A. Okay? So how do we do that? So we have 1, 2, 3, 4, 5, 6, 7, 2, 9. Okay? In order to get the value of the A11, okay, what are we going to do is we're going to cross out, since this is A11, we're going to cross out the row 1 and the column 1, and then get the determinant of A22, A33, and the remaining 2 by 2 matrix here. Okay, that is what we are going to do for the rest of the values. So if I'm going to get A11, I'll be having A22 minus A33. This is the point of interest. So if we are going to get the A11, we are going to cover column 1 and row 1. So that would be 5 times 9 minus 6 times 2. That's the determinant. So you have 45 minus 12. So you have 35, 33. Okay, for A11. Now the same thing we are going to do with A12. Okay? So how do you find now A12? Okay. So for A12, we are going to cross out the row 1 and the column 2 and then get the remaining determinant of the determinant of the remaining elements. Okay? So that's clear. Okay? We just simply would follow this cofactor matrix. Okay? So it's clearly that we can cross out this, and we have 5 here, and cross out this. Then get the determinant. And that is our A12. So that would be 4 times 9 minus 6 times 7. So that is 36 minus 42. So that would be negative 6. Okay? Same thing happens with A13. What are we going to cross out with A13 is the row 1, and then, of course, instead of the column 2, okay, we are going now to cross out what? Column 3. So A13, this is still row 1, cross out row 1. And then we have column 3. So you have now the values here. Okay, I'm just going to cross out row 1 and then column 3. So you have 4, 5, 7, 2. Okay, so you have 4, 5, 7, 2. So I have 4 times 2 minus 5 times 7. So doing this for the remaining elements, Okay? It's simply just very easy because we are only dealing with 2 by 2 determinants. Okay. So, let's do this. So, you have 4 times 2 is 8 minus 35. So, 25, that is negative 27. Okay? So, 25, 27. Okay. So, again, let's do it. Here. Okay, if I'm going to get A21, let me just rewrite. If I'm going to get A21, I'm crossing out row 2 and then column 1. And then I'm going to get the determinant of the remaining. So you have 2 times 9 minus 3 times 2. So that is 18 minus 6 and that is 12. How about A22? Let's do it again. So you now have row 2, column 2 crossed out. Okay, so we have 1 times 9 minus 7 times 3. So you have 9 minus 21. That is negative 12. You have A23. Okay, so for A23, we are going to just cross out still row 2 and then column 3. So what we are going to do here is, again, get the determinant. So you have 1 times 2 minus 7 times 2. So you have 2 minus 14, which is negative 12. Alright? So doing it again for A31, A32, and A33. Okay, so what are we going to cross out? So A31, so we have row 3, then column 1. So you now have A31, you have 2 times 6 minus 5 times 3. So you have 12 minus 15, that's negative 3. Then A32, you now have row 3, column 2. So we have row 3, column 2. So you now have 1 times 6. Then minus 4 times 1 times 6, this one. Then minus 4 times 3. 6 minus 12, that's negative 6. And then finally, okay, the A33. Row 3 and then column 3, crossed it out. So you have 1 times 5 minus 4 times 2. So you have 5 minus 8, which is negative 3. So you now have all the values of the cofactor matrix. So I'm going to rewrite the cofactor matrix here. Oops, sorry. Cofactor. So you now have 33. You have the 33. A12 is negative 6, negative 27. A21 is 12, negative 12, and negative 12. You have negative 3, negative 6, and negative 3. This is our cofactor matrix. Alright, so that is our second step. Okay. So, and then, the third step is we're going to apply the sign convention, which is positive minus positive, minus positive minus, and then positive minus positive, to our cofactor. So, what does that mean? We are just going to simply multiply these signs to our cofactors. So, positive times 33, positive 1, so that's 33. We have negative of the negative, so this becomes positive. Then we have positive times negative 27 would be negative 27. Then we have negative 1 times 12, that means negative 12. positive times negative, that's negative 12. Negative times negative, that would become positive. Then we have positive to negative, that's negative. Negative to negative, that's positive 6. Then you have positive to negative, that's negative 3. That is the cofactor with applied sign convention. This is very important. Okay? So don't forget this step. Actually, all of the steps are important, so we should not forget the, the signs. Okay? So, for number 3, we are done. For number 4, we are going to get the transpose of that matrix. Okay, let's say the A transpose of this matrix with the applied conventions. So, simply, we're going just to, this is row 1, okay, or column 1. I'm going to make it as, okay, our row 1. So, 33, negative 12, and negative 3. Take note, what I've taught a while ago is that getting the transpose is just simply interchanging the rows and columns. So, this column 1 becomes the row 1. So, same thing that I will do with the column 2. The column 2 becomes the row 2. That will become 6, negative 12, and 6 in here. Okay? So, it's just like I'm just reversing, okay, the process. So, this is column 1, it became row 1. This is column 2, it became row 2. So, you have 6 here. And lastly, for the column 3, it will be the row 3. So, you have negative 27, you have 12, and negative 3. This is the A transpose of the cofactor signed matrix. Okay? So, the steps should be logical. So, you get the determinant, you get the cofactor, you apply the sign convention, and then you get the A transpose. And lastly, the final step would be to get the A inverse, or the inverse of the matrix. We need to multiply it by the 1 all over determinant of A, okay, multiplied by this transposed matrix. Okay? So, what is 1 all over determinant A? Our determinant is negative 36. So, you have 1 all over negative 36 in here. And then you have 33, 6, negative 27. You have negative 12, negative 12, 12, negative 3, 6, and negative 3. So, it will be multiplied to every element. That this is scalar multiplication. So, this will be, negative 136 will be multiplied to every element in the matrix. So, now it becomes 33 or negative 33 over 36 because of the negative. So, negative 6 all over 36. Negative 27 all over 36. Then you have negative 12 all over 36. Sorry, it becomes positive because of the negative 12 of the negative 36. Negative times negative would be positive. So, this will be also negative 12, negative 36. And then you have negative 12 all over 36. So, I just write the negative already here from the negative 36 since this is positive. So, you have negative 3 all over negative 36. 6 all over negative 36. Okay? And then you have negative 3 all over negative 36. So, this is just very simple since we're going just to get the lowest term of this. Of course, including the... Okay, so this becomes negative 11 over 12 by lowest term. Okay? And this becomes negative 1 all over 6. Okay? Divisible by 6. Okay? This becomes what? Negative 27 all over 36. So, that becomes negative 3 all over 4 by 9. 9, 18, 27, 36. Then, 12 all over negative 12 all over negative 36. That becomes negative 1 or positive. I mean, negative divided by negative is positive. So, you have 1 all over 3. And this one, negative divided by negative is also positive. 1/3. Because if we divide by 12, that will be 1 all over 3. So this becomes negative 1 all over 3. Negative since, okay, we have a positive 12 here multiplied by a negative 1 all over 36. So positive divided by negative or negative divided by positive is negative. So for this one, we have positive. So negative divided by negative, that becomes positive. So that would be 1 all over 12. Okay? And this would be, okay, negative 1 all over 6 divided by 6. Negative because positive divided by negative. Then lastly, we have what? Negative divided by negative, that would be 1 all over 12. That would be a positive. So this will now be our inverse matrix. Alright, so this will be our inverse matrix. But then again, okay, correction, we have here negative 27, this is negative already, and multiplied by negative 36, so this should be positive. This positive 3 all over 4. So this would be a positive. Okay, again, because we have negative 27 multiplied by negative 36, so this would be negative, negative. I haven't written the negative here. So this should be the answer. Okay, anyway, the sign is positive. Okay, so this is the inverse of our matrix. Okay, so for your exercise, okay, so you can you get the inverse of this matrix, where matrix A is given by 0, negative 1, 2, negative 10, 5, 3, negative 4, 2, and negative 1. Okay? Type in the comment section your answer so that you can test your knowledge whether you learn the steps or not. So you can repeat the steps here so that you can answer this exercise. So again, this is Injir Abad. Thank you so much for listening for the tutorial of the inverse of a matrix by 3 by 3. See you again on the next video.